Well, all right there now. It's Mrs. Allen here, and I'm looking at doing a practice problem, rate in and rate out free response. And if you look at this problem, we have a table, and it says at time t equals 0 minutes, a small kiddie pool has 120 gallons of water in it. Well, that's the initial water. A small hose is used to fill the pool with water at a rate modeled by h of t gallons per minute, where h is differentiable and decreasing. H is differentiable and decreasing from 0 to 4, t equals 0 to 4. And selected values of h of t are shown in the table above. So now looking at the table, h of t is a rate, but there's no derivative marking on it. It's not called a derivative, but we know that once we're talking about a rate, we often relate that to the first derivative, the rate of change. So there is a small hole in the pool that causes water to leak out of the pool at a rate modeled by L of t is equal to 25t over the square root of t squared plus 9. So the first thing I note on a problem like this is the information in the table that we're talking about a rate in, rate out. There's kind of a balancing of things going on, water going in, water going out. So it's kind of like when you're riding a bike and you're riding into the wind, your speed of the bike, if you're riding 18 miles per hour and you've got a 2 mile per hour headwind, that means you balance your speed by 6 and you're pedaling 18 miles per hour, but your actual speed is going to be 2 miles per hour slower. So 18 minus the 2 for the headwind. And so if you're looking at this, you have, okay, the rate in is the filling h of t and the rate out is the leaking. Then in this, we're talking about rates coming in, rates going out. And in the first problem, we're talking about find the total amount of water that leaks out of the pool. So from your integral of a rate, you know that you get back to the function, so to speak. And when we look in analyze the units, we have gallons per minute that the water is leaking out, and it's times minute. And so we know that when they cancel, we're just left with gallons. So this expression, the integral of the rate of the water leaking out, will give you the gallons leaking out. So we just plug in the function. So find the total amount of water that leaks out of the pool from t equals 0 to t equals 4. There it is. And so we say, we take a look at this and say, how am I going to integrate this? So this is a non-calculator problem. So we would then just say u is equal to t squared plus 9, and du is equal to 2t dt. And then we're just going to say du over 2 is then equal to t dt. So I'm going to do a substitution. I'm going to take the 25 and pass it out in front of the integral. And then I'm going to have the t dt is going to be taken up by the du over 2. And we have 1 over the square root of u times du over 2. And then at the same time, I'm going to change the limits where I have the top limit is 4 squared plus 9. And that's going to give me a 25 for the upper limit in u. 4 squared plus 9. I'm going to erase that then. And then for the bottom limit, I just have 0 squared plus 9, and that's going to be 9. So now I have my new integral in u set up. And so now at this point, I'm just going to clean things up a little bit. 25 over 2 out front. And then we have the integral of u to the negative 1/2 du, and that would be from 9 to 25. Oops, put 20 instead. 25. And so when we integrate this, we leave the constant 25 over 2 out front, and then we get times u to the 1/2 over 1/2. And then we would evaluate that from 9 to 25. That's then going to give us just a 25 square roots of u evaluated from 9 to 25, which would then be 25 times the square root of 25 minus the square root of 9 using your fundamental theorem. And then we get 25 times 5 minus 3, which is just 2. So we end up with 50, and that would be 50 gallons. There's our answer for A. So the amount of, let me go square there. The amount of gallons that leak out of the pool would be 50 gallons. Okay, now for the next part, is the amount of water in the pool increasing or decreasing at a time t equals 1 minute? Show the work that leads to your answer. So what we have are rates coming in, rates going out. So just like I explained with the bicycle, in order to get the balance of the rates coming in, the rate of the water coming into the small kiddie pool and the rate of the water leaking out, we would just take the difference. So with this expression, you want to know if the amount is increasing or decreasing. Well, we know that we have to look at the derivative. We evaluate the derivative. If the derivative is positive, the rate is positive, then we know that the amount is increasing. If the rate is negative, then we know that the amount is decreasing. So with this, we're just going to say, here's our expression. We're just going to say h of 1 minus L of 1. And then we have to look at the table for h, and it looks like h of 1 is 13. So h of 1 is 13. So we have 13 minus, and we have our rate is 25 times t, which is 1, over the square root of t squared, which is now 1 squared plus 9. And that turns out to be equal to 13. Now we have our difference. It's 13 minus 25 over the square root of 10. And I'm going to do a quick estimate and say 25 divided by the square root of 10 is about 8 something, because it's like 24 divided by 3 would be 8. So this would be 13 minus about 8 something. So it's still going to be a greater than 0 rate. So since this difference, h of 1 minus L of 1, is greater than 0, so we can say that. Therefore, since h of 1 minus L of 1 is greater than 0, then the amount of water, I could speak more fluently, I guess, then the amount of water is increasing. And if you notice, what I did in this problem, just like the previous one, I unlocked what the problem was about. So in A, it was the total amount of water that leaks out, the interval of the rate leaking out. And for B, what is the amount of water increasing or decreasing? That means I want to look at the leaking derivative and see the filling minus the leaking to see, is it positive or is it negative? So we know because it's positive, then the amount is increasing. For the next one, I highlighted the left Riemann sum with the 3 subintervals given by the table. And I've kind of copied the table here. So I want to use a left Riemann sum with 3 subintervals given by the table to approximate the total amount of water poured in. So I'm only talking about the filling. So I'm looking at the table up top. And so we know that when we do a left Riemann sum, we look at our table and it says with the 3 subintervals given by the table, I'm not going to be calculating a delta t is equal to b minus a over n, 3 in this case. What I'm going to do is I'm going to look at the table and read it and see the delta t's that I have. So what I have is I have the integral. So you see the integral in the first place from 0 to 4 of h of t dt is approximately equal to L of 3, which is equal to the summation from I is equal to 1 to 3 of h of t sub I times delta t sub I. And those delta t sub i's are different in this case. So what we're going to do is we're going to look at the data, and it looks like we start off with 30 is the h. So I have h of, let me do the notation here, h of 0 times its delta t, which is 1, plus I have h of 1 times its delta t, which is 2. And then I have plus h of 3. Am I at 3? Yep, 3. And then that's going to be times its delta t, which is 1. The delta t going from 3 to 4. And then I'm just going to plug the values in here. So I get for h of 0, it's 30. 30 times 1. Plus h of 1 is 13. 13 times 2. Plus h of 3 is 5. So it's going to be 5 times 1. Oops. So then I add them together. So I get 30 plus 26 plus 5 is then equal to 61. And that would be 61 gallons that have leaked out of the tank, or the pool for this matter, the kiddie pool. Okay, so the answer here is 61 gallons. take this check mark here and just say 61 gallons. So, okay, here it's increasing. Now, on the last one for this video, I'm going to go over D. Using the result from part C, approximate the amount of water in the pool at time t equal 4 minutes. Is this an over or under estimate? Now, we just did something where you want to think, okay, we have an estimate that we're doing there, right? And so that estimate, because H is decreasing or increasing. I believe it says in the beginning, if you scroll back up, you got to sometimes check that it's decrease. H is differential and decreasing from 0 to 4. So if we're doing a Riemann sum and it's a left Riemann sum, look over here where I have H of t is the curve that I'm kind of mocking. But as it's decreasing, we do a left, we have an overestimate. Okay, so we have an overestimate for, oh, I'm sorry. Let me pause the video here just for a second. Okay, so we're going to go back and answer that question, but we have W of 4 is the amount of water that we want, and we already know these two. So we've got 61 gallons and 50 gallons. 61 gallons are going in, 50 gallons are going out. That's a serious leak. So we have W4 is the equals the amount of water at the start. And we know that at the beginning, I think it's 120, right? 120 gallons you have in the kiddie pool. Plus, then we have the integral of H of t from 0 to 4. And so that's going to give us the 61. And then we've got to subtract off leaks out in the first four minutes. And that's 50. And so when we combine these together, it looks like we get 131 gallons. So set up. Okay, there's our answer. And then we answer the question, is it an underestimate or an overestimate? And I think about this for a second. If we're looking at this and we have this extra area, we're just taking a look at this. And this is always true. Let me make that a little bit thinner. So it's always going to be true if you're looking for estimates. And you see where I have this extra area up here? If we're doing a left Riemann sum and the function is decreasing, that's all we have to say for our answer is, look, H of t is decreasing. So the left Riemann approximation method will be an overestimate. Can I fit it in there? Okay. All right. So this is one problem, and we'll continue our work with this one problem with rate in, rate out, but this will be enough for the first video. So I'll be back with you in just a minute. Hang in there, stay safe, stay well, and stay positive.